Well, all right. So, so Sumati is saying that the GoToMeeting crashed and is it available? Actually, that's not available. The first half, first 1 hour, I think, is gone. That's why I've started the other kind of recording today. Okay. So I don't know what is with this GoToMeeting. Sydney is saying, can you explain the line number 5 average equals to group for each group generate group and average of divs dot value. Okay, this one. All right, all right. So which page is this? Which slide is this, Srini? All right, let me explain to you. So here grouped is equals to if you by a certain factor. Which slide is this, Srini? Are you listening to me? So all right. Probably this is the one you're talking about. All right. So, yeah, is this clear to everybody else? All right. So first we load the data from NYSE dividend, and this data is tab separated. So it's loaded as 4 columns: name, ticker, date, and value. Okay. And then we are grouping divs. We are grouping divs by ticker. All right. So let's go one step at a time. All right. Now, if you see explain divs, so divs has describe divs. So divs has 4 columns: name, ticker, date, and value. All right. Now, next step is we group it by the ticker. Okay. Meaning second column we are grouping it with. Now, when you say describe GRPED, probably this will answer your questions. So now GRPED has got 2 columns, or you can say it has got 2 fields. One is called group and other is called divs. Alright. So in the group The name is so the group is a byte array. All right. So whatever column you grouped on, that will be the value of this column called group. Okay. So here, so this we since we have grouped on ticker, so the value of group will be the ticker value. Okay, each one. So it will be first will be CPO and this and that. Okay. And in the divs, you will see there is a bag of tuples. There is a bag of tuples, and each tuple of this type. And if you look at it closely, so basically divs is a bag of this divs. Okay. So in this group, the column name of the field where which has aggregated the various records is also called divs, same as the data set which was grouped. Okay, you see that? And generally, this is the minor thing which is what do you call which is a little source of confusion, but once you have a look at it, then you will have the clarity. Also, you should try dumping group grped, as well as you should try dumping divs. Then you will understand that what a kind of data structure is grouped. So grouped is nothing but a bag of values. Okay, and the bag is containing each tuple of type of name group, and this tuple the group is containing the tuples which has two fields, group and divs. Divs is further another bag of tuples, and tuples containing first column as name, ticker, date, and value. And now when we say averaged, okay, what does it mean by average? So we are saying for each grouped, okay, meaning for each tuple of this bag, generate generate group is this column, okay, and average of divs dot value, average of divs dot value, meaning average of the value which is there in this tuple. So the column called value will be averaged for each group. Okay, does it make sense to you now, Srini? All right, was this to your confusion? Okay, all right, moving on. Good, good. So all right, so we were here, we had discussed all kinds of joins, and had also discussed the full join. All right. All right, question to all of you is this: what will be the output of this statement, or will there be an error? So I'm saying there is a dataset A and there is a dataset B, A and B, and we are saying join A by ID and B by ID, or left outer. Okay, so what will be the output? If there's no output, will there be an error? That's right. That's right. So, okay. So Peter got it right. The there would be an error because left or right makes only sense when it's in the middle. Okay. All right. Good. Good. Next question to all of you is when we are joining A, so we are saying join A by ID and then outer comma B by ID. Is this correct? What will be the output of this one? Correct. It should specify left, right, or full. Thank you, Rohit. Good. Yes, that's right, Peter. All right. Sometimes we only want first few records, okay? Or in those cases, you could use limit. You could say divs equals to load NYSE dividends. First 10 equals to limit divs 10. And then you say dump first 10. All right. Now, there's an interesting function called sample. And what does sample do? Sample basically gives you a fraction of the total data set in a randomized fashion. It basically picks up a fraction or random subset of the total records and and uh, gives it in another data set. So sample devs point 0.1 means it will give us 10% records. Okay, so that's about the sample. All right. So I hope the sample is clear to you. All right. Here is a question which gives a different answers. So question is devs equals to load file.tsv and then sum equals to sample devs point 1. Okay. And then we are saying dump sum and dump sum. So if you run dump sum twice, will it give the same result, same output, or will it give different output? So in sum, actually the command is stored. All right. So here is some theoretically it should give the different outputs. Okay. But yeah, but since this function called the so for a session the seed which sample uses is same. Okay. So although every time you say dump sum, it will create everything, but since this sample method is pseudo randomized, okay, it's pseudo randomized, therefore it actually gives the same result. Alright. But if you run the full script again, you will get different results. Alright, so theoretically, the whole thing is computed again, but since the sample command is having the seed, random seed generated, and which is same for a session, therefore the randomization, although the whole sampling process is repeated again, it okay, it gives the same result. Okay. Earlier in the previous versions it was different, but now in the recent versions it gives the same result. If it is run in the same session, the output will be same. If it is run in a different session, the output will be different. Okay. All right. All right. So now let's talk a little bit more about how does Pig optimize various things and how can we control Pig to do the optimization for us. So parallelism is a big promise. I mean, basic promise. If you remember our basic premise, pigs fly. Pig was designed for the performance. So parallelism is the basic promise of pig, and it basically the parallel keyword basically controls the number of reducers, although it does not impact number of mappers. Alright, so the syntax generally is if you, let's say there is daily equals to load NYSE daily, and then when we say group daily by symbol parallel 10, okay, so it actually creates 10 reducers in parallel. Okay, so it's like saying that setting reduce task equals to 10, it's equivalent of that. All right, if you do not apply the parallel clause, pig decides on number of reducers by itself, and the way it decides is it it decides based on the input data to your MapReduce process, because before launching the MapReduce process it doesn't know anything about anything else other than the input data. So it allocates, if your file is 1 GB, there will be one reduce task. If there are 20 GB data, there will be 20 reduce tasks. And if there are, and it keeps on doing that, it keeps on creating one reducer per 1 GB data, but it does not create more than 999 reducers. Okay, so that's the default behavior of pig. If you do not put parallel keyword, it generates those number of reducers automatically. Okay, so it generates one reducer per gigabyte up to 999 reducers. It doesn't go beyond 999 reducers. But if you are specifying parallel keyword, you can specify above 999 reducers. All right. Generally, the parallel keyword has to be applied on the statement at the end of it. Okay, but if you do not want to apply at every statement, you can set a variable like set default underscore parallel space tab space 10 or whatever number you want to set. So so that will set the number of reducers in the whole script. All right. So you don't have to. Now Sumati's question is, how do we determine number of reducers? Okay. All right. So the first idea about number of reducers is know your cluster. Okay. Know your cluster as in find out how many reduced tasks each can execute. Okay. So you can find out from the Ambari that how many reduced tasks in parallel can be executed by each node. Okay. So know your cluster as in the total reduced tasks which your cluster can execute. If your cluster can execute 50 reduced tasks, okay, uh, so then second, the the total number of maximum reduced tasks mm, is sorry. So your reduced task can vary somewhere between 0.95 to 1.75 times the max reduced tasks. Okay, notice that the total number of reduced tasks can go above the max tasks possible. Okay, reason being these things are done in parallel, and it's okay if it's okay if it goes a little above. All right. Now, so a general thumb rule is you start with one reduced task and then you try 0.95 times the max. Okay, let's say the max is 20, so your max is 20, so this is going to be 19. So first you try 1, then 19, and then see which one is faster. If one is faster, then you try somewhere between 1 and 0.95 times the max, and you keep on doing that kind of a search. So I mean, that's one recommendation. And observe whenever you are running MapReduce task, observe if there is a lot of time taken by reduced task, you increase the number of reduced tasks. If there is a lot of time going in shuffling, you need to reduce number of reduced tasks. Okay, you need to decrease number of reduced tasks. All right, I hope I've answered, Sumati. All right, so there's a question from Anand. The question is, input equals to this. I don't think anything wrong with it. Just a second. Just a second. Input equals to load this as line. This is correct. There must be something wrong with the line 4 column 0 mismatched. Mismatched input equals to I think there is a keyword called input. Yeah. Yeah, there's a keyword called input actually. All right. So do we have it somewhere? All right. Now going ahead. Now, quick question to you. How many reducers will it produce? Anybody? It's a for each task. And what for each does? Basically execute your logic on each record. So none. That's correct, Dilshan. Yes, it will have no reducer. So will there be an impact of parallel clause? Correct, correct. So parallel clause will have no impact on for each. All right, good. All right. So sometimes you will find that lots of functions are not available in the pigs library. There are, although it's fairly exhaustive library, but lots of time a particular function that you're looking for is not available, and therefore and therefore you can you will have to use external functions. Okay, so or maybe there is a proprietary code that you want to execute and which cannot be available in the library. In those cases also you will have to use the external functions. All right, so let's say we have a function in Java and there is no such function, corresponding function in Pig. Now, to, and we want to execute it. Let's take, for example, integer.toHex string, okay, which takes an integer and converts it into hexadecimal string. So that function we want to use and it's not there in the Pig library. All right. In those cases, what we can do is we can say define your hexadecimal function here as invoke for string, and here we mention int to string. Okay, and it takes an integer, returns in string. That's why we are saying invoke for string. Okay, then we inside the for each we can use this function. All right, you can try this out, it should work fine. Now, please notice that if we are going to use Java built-in, we don't have to do anything other than defining the function and then calling the function. Okay? But in case there is your own library and you want to call the function, you will have to first register it and then define a method like define convert, and this is the class that contains the convert method, which takes two arguments, dollar and euro, and then you can call that function. We will show you a proper example of UDF. This is your UDF, user defined function. Okay, if you have a Python program and you want to call its methods as if they are the methods in Pig, so all you have to do is you have to register your Python program. Now here the way we are calling is register Python production.py. Now production.py should exist in local file system in the folder from where you started Pig. Okay. Same is the case here also. When we say register this, okay, the moment you say register, it will load this file and find out all the functions that are listed in this file and make those available as part of our ball. Okay, we are giving it a name as ball. And then we can call various functions which were available in this production.py as if they are part of pig. Okay, you can say for each some data set generate name, I mean some column, and then you can call the function. Say there is a function called produce in this production.py. We can call that like bball.produce, and then okay. So that gives us a great flexibility in terms of executing anything as a function. So let's try to create our user defined function. So Rohit's question is, what is the first parameter for invoke for string? This first parameter is the name of the function, fully qualified name of the function. So there is a 2-hex string function in integer class which is in this package. So java.lang is a package, this is a class, and this is a function. Alright, let's try to create a project. Uh, let's try to create a user defined function. So for that you'll have to download this project. You will have to download this project and then import this project into Eclipse, and then fix the dependencies. It would basically require only one external jar called pig.jar, which is available in the project itself. Okay, let's have a look. So Pankaj's question is, so we can use call static methods only? No, you can call the other methods as well. Okay, you can call the other methods as well, the way I have mentioned in the second one. Okay, we'll get back to this again. All right, so all right, so there is this big UDF. You can basically import, or you can create a fresh project. You can create a fresh project and add pig.jar into the reference libraries. You can see we have we have the reference library here. Okay, so yeah. Try importing that project and it would be there. This pig.jar would be in that project. If it is not working, you can just create a fresh project and take the pig.jar available in that folder, which is here. Let me give it to you. All right, so here you will see that we are creating we are trying to create a function called upper, which will be using that as function inside our piglet. Note that for each function which we want to create in piglet in any UDF, we need to create a class in in Java. Okay, so we have to create a class called upper, and then extend the eval function while eval and specify whatever return type is there. So since our function called upper is going to return a string, so therefore we have mentioned a string, and whatever you mention here, you'll have to mention it here, okay, in the return type of exec method. So whatever function you want to create, you have to create a class for it, and then this class should extend eval function and eval func, take the first argument as string, and then create a method called public whatever data type you have here, okay, and exec, and then you will get a tuple as an argument. So inside it, you do all of the logic. Here we are saying first checking if input is null or input size is 0. Okay, then return null. In case input dot size is not 0, then generally input dot in the 0th element is what we are doing the to upper on. Okay, if this tuple has more values, rest will be ignored. Only the first one will be taken to do the to upper, and then we are returning string.toUpperCase. Here we are using a Java function. Okay, so we can do anything we want here. Let's say we want to put double quotes before this. Okay, let's say we want to put dashes before it. Okay, uh, just like that for the fun sake. So we are converting it to uppercase every string and putting dashes before and after this. All right. Now let's try to export it. So I'm saying jar, and then I'm saying sg-pig udf, and that's it. So it says already exists. I'm saying override. All right. Now let's copy it. Say scp downloads. This is where I had kept. This is where I have kept this. I'm using a command called scp. You don't have to do this. You can use simply winscp. You can download winscp and copy to the server, or you could first copy to Hue and then do a copy to local from Hue to your local directory, just the way we did for Hadoop jar, MapReduce jar. Okay, so we are doing scp, which is like secure copy over the wire, and we are going to copy it to T7974, that's our login, and h3.cloudxlab.com. Okay, sorry, we have to say colon also. Now it's asking for, alright, so it has copied the data sg-pig udf. Alright, now that is done, we say register sg-pig udf.jar. So now we have registered sg-pig udf jar. Okay, now let's say there is a file called this one, and what is there in this file? Let's first check that. Cat this. So it has all small a11, a21, and so on. Now let's say we want to run our UDF on top of this. We loaded that file. Now we are doing for each. Let's say dump B. Alright, you can see that it has put dashes around it and also converted it to uppercase. Okay, so howsoever you want, you can run the functions. Alright, sounds good to you? So we were able to successfully create our own upper method. Alright, let me exit Eclipse before it crashes my laptop. Alright, now let's answer one more question. So question from Pankaj is, can we only use a static method from Java? Okay, so here you see the second definition. What exactly is going on here? We are defining something called currency converter. All right, I think I'll have to come back with this. Okay, so let me come back with this. Let me reply to it. Okay, so we can call the methods from Java. We just have to first create an object and then call the method on that object. Okay, let me come back to you with the proper example. Here I don't have an example. Yeah, so in the currency converter, we are here. These two arguments are for the classes constructor. These are for the class constructor. Okay. This is actually for the UDF. So when you have defined your UDF, this is actually for UDF. This when you have defined your UDF and you want to pass the constructor argument to this, then you can pass it like this from here, and then use this convert function everywhere. All right. All right. Sometimes, all right. So sometimes you have to integrate with the legacy code. Okay, let's imagine for time being, it's a shell script. Sorry, it's a Perl script. Perl was Perl is a programming language like Python, and is quite heavily used wherever there is a text extraction or text parsing involved. For example, in D Sharp, the all the code that was written before 2000 was in in Perl. Similarly, you would not believe this. The Amazon.com's website, okay, most of it is still in Perl. Right? So Perl is quite a famous language, but people do not use it anymore, right? So when you join an organization, let's say you join a large organization such as Goldman Sachs, and there you will notice that there will be a lot of legacy code, and this legacy code is not so easy to rewrite because there's a lot of business logic, and you cannot take the risk of rewriting the business logic, because if you go wrong at any point of time, it will be difficult to fix and difficult to detect, and it might cause a lot of damage. Also, since a lot of legacy code does not have test cases, it's difficult to generally revamp. All right, and sometimes your requirement is not that big that we have to revamp everything just for one big script, right? So what we need to do generally is, in case you want to call the legacy code, okay, you basically have to use streaming. Stream is not like YouTube streaming, not like stream processing, like using the queue and all. Here, the streaming means the way the command called SED. SED is what? It replaces the data in the input and puts it in the output, right? And SED's full form is stream editor. Okay, so most of these tools which are in the we used in pipeline in Unix are basically streaming tools. Okay, this called streaming, as in we are streaming data through a command. Okay, so this streaming is similar to what we had Hadoop MapReduce streaming. Okay, so we could stream the data through the legacy code using the keyword here called stream. Okay, we are saying stream divs through hidiv.pl as exchange symbol date and dividend. All right. All right. All right. So we are saying stream divs through hidiv.pl, and here the quotes are backquotes. There's a purpose of keeping the backquote so that in case your command involves other arguments, you can put them, and in case you need a double quote there or single quote there, you can happily use those. Now, sometimes this program may not be available on all the nodes. Okay, if your program is available on all the nodes, we are good. We can also specify this program as, say, user opt something, okay, or say opt slash whatever is the actual path name, we can provide that. But sometimes it may not be installed on all the nodes, and that's where you have to use ship. So here there are two things which we have mentioned. First, we have mentioned argument to this program. We have to mention, we wanted to mention some argument. So one, we have mentioned the argument. Second, we are saying ship means take this pl, take this perl program, ship it to all the nodes, okay, and then execute it. And you just have to define it in the beginning, saying my function name is hd, it is equal to this, which is shipped, and this file need to be shipped for this to be executed. And that is where okay, so that's where the definition of this function happens. Afterwards, you can use hd as if it's a local function. So we can say here stream divs through hd as this. Okay, what does it mean as? It means whatever is the return, whatever value returned by hd should be considered as the four columns, which means hd should be returning the hd should be returning these four columns separated by tab. Or the way you can look at it as if we are loading data here. Okay, so we are saying as, and then we can also say using big loader. Okay, if it is, if hd is returning comma separated values. Alright, so that's how you can call the legacy code. Sometimes there are a lot of very common function. Let's take a case of CSV parsing. The default pig storage, which takes a comma as takes separator as argument, is very rudimentary, right? So the default behavior of pig storage is very buggy. The question which we have given you regarding the tweets, okay, in the exercises, in that you have to use the pig storage, and that pig storage is taking the comma. Now that's buggy. Reason being that in case comma is there in the field in the column value, then the pig storage is not able to parse. You will notice that those tweets which we are using, some of them have comma in the data, and that's where it will give errors. Okay, you will see that it's not able to parse a proper CSV. In case of CSV, there's a way to comment out the comma by putting double quotes around it. Okay, so this default behavior of CSV is not good enough. Okay, is not good enough, and that's where you have to utilize the external storage functions. Okay, so instead of using pig storage, you can use CSV Excel storage. But the problem with CSV Excel storage is that it's not part of the core, it's a contributed library, and all the contributed code is kept in piggy bank. What is piggy bank? Piggy bank is an open source repository where all the people like you and me, if we want to contribute our code, we commit there. Okay, so we contribute to the piggy bank, and you can generate your piggybank.jar by yourself by checking out the code and then running the ant will generate the whole project. Okay, also I have done it for you. I have put one piggy bank jar in the in the in the in this data slash pig folder. You can have a look at that. Okay, so you can use that. So you could say Hadoop fs minus ls. This actually we could have done from the pig command line itself. That could have been easier. So you can see that we have already capped a piggybank.jar. You can download it, copy to local, and start using, register it, and start using the functions mentioned it. Now, what all functions are available? You can go to this Confluence page of piggybank. There they have mentioned all the functions that are available. All right. So to use CSV Excel storage, you will have to use piggybank.jar. All right. Now there is an interesting function called for each nested. Now in case of so let us say you have a big file containing city and the name of the people. And what you want to do is you want to count the unique names in each city. Unique names as in Bangalore has three persons, Sandeep, Vivek, but the unique is only, Sandeep is repeated, so unique is only two, right? Similarly, New York has John and John, so and the unique is only John, so New York has one. So we want to do this, we want to count unique number of people. Now, how do we do this? Yes? Anyone? Yeah. Yes. So you have to find the counts of distinct names. We want some script which can convert this into this. So Anand says distinct city common name and then group by city. Good, good. Yes, yes, we could do that. So basically, all we can do is first compute the distinct and then do the, okay. So if we do just the distinct on the tuple, we should get it. But what if there is one more column? All right. What if there is one more column here? Then we have to project it and then do. Okay. So to make the life easy, sometimes whatever data set we have here, sometimes we want to call for each twice, or we want to call the other distinct methods, other methods inside the for each, right? Like the way we have group here outside, we if we sometimes want to do grouping inside the for each as well. Therefore the concept of nested for each comes into play. What nested for each does is, if you put the curly brackets here after for each, it makes the two data set, the group and the data set which was grouped, meaning people, it makes those two data sets available within these curly brackets so that you can call these basic transformations such as for each and such as group by, order by, distinct, whatever we have studied so far. You can use those inside the curly brackets on the members of the GRP, or members of the one on which we are running the for each nested. So we are calling distinct on people, okay, and then people dot name for each of the groups. So you can notice that people which was basically a big bag of the values for each city, is available as a data set inside it, and we are calling distinct on it. Okay. And then we can generate group comma count of dnames. Okay. So basically for each makes it possible to do the nested for each. Inside for each you can further have, here you can have another for each. All right. Yes, that's correct, Peter. That's what we have done. Thank you. And yes. All right. Sumati, that strategy is also correct. We distinct by names and then group by city. Yes. All right. All right. Great. Great. Moving on. So this was for each nested, in which makes it possible, if you put the curly brackets, it makes it possible to call for each from within for each. All right. Now here is another interesting aspect. So we, I think, talked about something called map site join, right? In the similar fashion is your fragmented join. Let's imagine that you have two. tables which need to be joined, or two data set which need to be joined. Let's say there is one table containing 1 billion entries. This table contains the name of the person and the city where he is living in. Now we want to convert this into name of the person and ISD code of the country where is he living in. Now to do that, we want to join with another table called country and code. So name of the country and country code, that's what we have here. So if we join these two tables, all right. So ideally, if we join these two tables, there'll be our reduce phase, right? When we are joining the two tables. If we have reduce phase and we are trying to join these two tables, what would happen is there'll be a reduce phase and it will take a lot of time, correct? Ideally, we could just join the two tables, this one, the table 1 and table 2 on country, and then we could have just said pick up name and the code, right? That could have been fairly easy. So, but since one of the tables is very, very small while the other one is really big, the other one is this country code is hardly 100 entries. So, if you think about it, we could load it in the memory and do the lookup while running the map itself, right? If we are writing our map reduce, we would do it that way. Okay, we would do it that way, right? To do the same thing in the pig, you can simply say using replicated. So while joining persons, let's say this table name is persons, and there is this table name is CC. So we load persons, we load CC, and then join persons with the CC. And let's say earlier we joined it happily, just like that, and later we realized, oh, the second table called CC is very small, it can be loaded into the memory. Then you can simply say using replicated with the second table. Okay, and this way it will automatically copy this table, second table, onto every node and will do the joining in the memory itself rather than using the MapReduce for this. And this will make it really, really fast. Okay, on the map side, these joins are generally called map side joins. Okay, does it make sense to you? All right. Sometimes you have to join the skewed data. And what do we mean by skewed data? When there are too many keys for sorry, when there are too many rows or there are too many records for a key, while there are too few for some. Okay, and it's very classic in case of unstructured data that for some keys you will find there are billion rows, and for some keys there are hardly few rows. Okay, specifically let's take the number of users in the city. Some cities have hardly few people and some cities have thousands of people. Okay, I mean hundreds of thousands of people. So the number of values is getting skewed. Okay, so when the data gets skewed, so sometimes if you try to load it in memory, it will work fine, and sometimes it may not work fine because some other data is really, really huge. So when this kind of skewness happen, then you cannot right away use the join. If you use the right away the join the way it was, pig might end up overflowing the mapper or reducer. So in these cases, you can simply tell pig that it's a skewed joins. So uh, I mean, whatever key on which you are calling the join, it if the data is skewed based on that, for some of the for for some of the keys for that particular column, for some of the keys, if it is very big, if some of the sorry, extremely sorry, so let's say for some of the cities there are too many people and for some of the cities there are too few people, then in those cases the data is heavily skewed. I mean, when I say too few too many, if the ratio is above 10,000, okay, therefore using skewed can be very useful at that point of time. So these are various kind of augmentation to join. We are trying to optimize our results by using various strategies because you know your data better than Pig. Okay. Rohit's question is Rohit's question is how does skewed keyword o- optimize? Okay. So the quick answer is that it will try to form the key based on the other columns as well. While doing the map reduce, it will try to break it down into phases. Okay. Otherwise, what would happen is for some keys the reducer will get so many values and for some keys it will get too few values, right? In order to avoid those kind of circumstances, the way MapReduce works is, I mean, the way MapReduce is done in the key, we add, instead of only having city, we add one more field, okay, internally, and then we try to do the MapReduce in that fashion, okay. Or the other way of doing it is by using the combiner, and that also helps in this. All right. It internally, I think, uses the combiner probably. I'm not sure how exactly it does. All right. Now there is another aspect to it. This is called the using merge. So when we are joining two data sets and we realize that those two data sets are already sorted, then rather than pig having to sort them again, you could inform pig that hey, this is just merge. Then pig will not sort those data sets. All right. Why? Why is this an optimization? All right. Why is this an optimization? Can anybody tell? So let me ask you this question. So sorting an unsorted data is taking X minutes. Okay. Now, how much time how much time will sorting this sorted data take? So there was some data which you sorted and it took around X minutes, or let's say there was this daily data set which you sorted and it took around X minutes. Now, how much time after you have sorted this, how much time will it take to sort it again? Similar to X, very less than X, or higher than x, more than x. Yes, which one? So you had some data set, you sorted it, it took around x minutes, and now you want to you are again asking pig to sort it. How much time will the sorting take, resorting take? Anybody? That's that's correct, Srinivas. It will be similar to x. Okay, so generally we the only case, this only case would be very less than x will be in case of bubble sort, but that algorithm no one uses. Okay, there's an algorithm called bubble sort which basically keeps on checking whether the data is sorted or not. If it is not sorted, it keeps on swapping the positions of the adjacent values. Okay, and keep on doing it again and again. So, but nobody uses that algorithm because it's very slow. Generally most of the algorithm use either quicksort or merge sort. So therefore sorting the sorted data in case of pig will take a lot of time, generally equal to it takes around it takes further, it basically will be similar. And there is one situation where it can take high more than that in case of binary search tree. If you are forming a binary search tree out of sorted data, the binary search tree might end up becoming heavily skewed, as in all the data will keep on going to the right hand side. Okay, and therefore the overall sorting time will be really high. Okay, will be really high. So therefore it is important to know your data, that therefore it's important to know whether your data is sorted or not. Okay, I have seen the impact of knowing your data very much in my career. I have seen a big impact because of sorting. Okay, because of knowing that your data is sorted already. Okay. Also note that any data you save in HDFS after the reduce phase, it will be sorted by the key. So you can utilize that information in the next phase when you load the same data for further processing. Okay. So whenever you know about your data that it's already sorted by the key, then you don't need to sort it again and mark it as using merge. All right. Yes, Pankaj, you are right. Good. Very good. Now, moving ahead. So sometimes you want to group on the sum on a field and join on the same field. Okay, ideally in such scenarios you should use co-group. Okay, instead of grouping it and then joining it, okay, you should use co-group. If you are grouping it and then immediately joining on the same field, you should generally use merge. Okay, the one which we just talked in the previous screen. So we should use merge in the cases we have grouped on the same key and joining on the same key. Or if we are doing grouping and joining on the same key, we could basically use co-group. Okay, co-group is essentially grouping the data by the key and then joining the two data sets by the same key. So you can see that we are saying co-group owners by animal, pets by animal. Okay, so you can see first the data gets grouped based on the animal. Okay, here also, so you can see that Alice cat, Adam cat, Alice cat, Adam cat has been grouped together, and then whatever it has generated as the group, that that comes together. So one group and another group. Okay, so that gets joined together. So output will have three columns. First, animal. Second, the values from the left hand side. Third, values from the right hand side. And what will be the values from the left side? The groups of the rows. All right, makes sense to you? Moving ahead. Now, so a lot of times we have to concatenate the two files. Okay, so in those cases you could simply use union A comma B. All right, so the records from A will be put into C first, then records from B will be put into C. Sometimes we want to force in schema, as in we know that A and B both have the same number of columns, just that the columns are in different order. Okay, id column is has occurred in the is the first column in A, while id column is second in B. In those cases when the orders of the columns are different, you can impose schema on A and B. Okay, let's take a look at how does imposing a schema work. You can say union on schema A comma B. So A and B will be imposed on each other, and it'll look like this. So let's say there is A has two columns X and Y, B has Z and X. So when we say union, normally like union B comma A, it will put all the values of say B and then A, and there will be no particular concrete way of saying concrete way of getting the result. So you can see B12 A11 B22 B21, that's what we have here. Similarly here A11 A212 A21 and A22, right? That's what we get here. So the records are concatenated. Now sometimes we want to impose in schema. So in those cases, we'll say union on schema. In that case, it will generate three columns, X, Y, and Z, right? X, Y, and Z. Now, when placing the records from say B, it has got A and B, which is B12, sorry, X and Z. So B12 and A11, B22 and B21, and and since B does not have a Y column, it will be empty. And since A has Y column but not Z column, so Z column will be empty and the records will look like this. So you can see that the values for the column X are together here from both the data sets, B12, B22, and A11, A21. B12, B22, A11, and A22. You can see that the values from both the data sets have been combined together, concatenated together, just that it has tried to match the columns. Rohit is saying, how is the order of XYZ? You mean the order in the output? Yeah, order in the output will be generally the alphabetic while we are unioning. But yeah, okay. I mean, that's what I observed. You can try it. All right. Let's take a break for 10 minutes and back by All right. So should we start now? All right. Sumati's question is, all right, let me make a note of it. Okay. So I'll make the previous session available to you. All right. And next question is, how many more sessions are left? It'll be around six. So as per the plan, November 28, right? November 28 is the plan. So I believe that by November 29, we should be able to finish the course. Okay? Which means not four, actually, it'll be more than that. It'll be more than that. So we'll have two next, which will be H base and others, and then I think four will be good. In next four sessions, we should be able to finish. All right. After this, there'll be four more sessions. All right. Okay. So moving ahead. Now that was our union. If we join the two records without an ID, what will be the result? Quickly, anybody? So we are saying C equals join A comma B. What is the result? A are some data sets. Yes, that's right, Pankaj. We have to provide some ID column. Correct. Otherwise, it'll give an error. Yes, because as we told earlier, that the normal join requires the ID, the columns. Then, so what do we do if we have to do kind of a Cartesian product? If we have to take all rows and uh, combine it with all rows of B, meaning if A has got n number of records and B has got m number of records, and we are looking for total number of records as n into m. Each record of A combined with each record of B. If that's what we are trying to do, then how should we go about it? That's where the cross join comes into product. That's where the cross join comes into product. Sorry, uh, that's where the cross product comes into play. And so all you do is cross daily and divs. Yes, Anand, you wanted to say anything about union? Union just appended the two records from both the sides. That's all it did. It did not cross multiply. Okay, so you could use cross daily divs. And also note that in this cross product is a very intensive process. Okay, cross product is a very intensive process, and that you need to do it parallelly on 10 nodes. Okay, that you need to do it on 10 nodes parallelly. or maybe more based on your data. All right. Now, since Pig and Pig Latin is a la- scripting language, and it is used widely in the report generation. So it provides you a variable substitution. Let's say you are running a report daily and you want to provide a date as the argument. In those cases, then you'll have to you'll have to put a variable like this. You'll have to say my filter date daily by date, and date is not fixed but an argument. And to provide a value of this, you pass it from the command line. All right. Now, every time you execute these commands, you keep on changing these arguments and keep on running it. Okay. Keep on changing these arguments and keep on running it. Okay. And yeah. And in case these variables become too many, you put them into another file and then use that param file, okay, to substitute all the variables. All right. All right. Sometimes you have a big data set, and you want to split it so that you can prepare the subsets of it, or you can prepare the various kinds of analytics on top of it. Let's say that you are churning web logs, and part of the web logs there are different statistics you want to compute. Okay, on different subsets of this particular weblogs. You can create those subsets by using split command. You can say split wlogs into April 03, April 02, and April 01 based on different conditions. Okay, and what it does is it takes for each record, it will check against each conditions and accordingly put that record in those data sets. Okay, so April 03 will have all the records before 4th April, while April 02 will have all the records which are less than 3 April and greater than 1st April. Okay, all the records after these two timestamps. Now, April 01 will have 2nd April, greater than 2nd April, and less than 2nd April, and greater than 31st March. Now, what you notice here is a record could go to multiple legs. For example, all the records less than 4th April would go to April 03 as well as into April 02. Okay, as well as here. So you can see that the records of say April 02 will go to this one and this one. Okay, because of the condition if you look at it closely. And similarly, the records of April 1 will go here as well as here, while records after 4th April will be dropped. Okay, so I want to say is split does not mean that these things will be mutually exclusive. April 1, April 2, these three data sets will be mutually exclusive. Instead, it will be based on these conditions. All right. Now, a lot of time Pig does a lot of optimization. A non-linear execution is one of the properties of Pig. For example, for example, unlike our C program or shell program or Python program or Perl program, it doesn't execute from top to bottom. it executes only the things which have store or dump and then walk backwards. Okay, so so from the dump, from the store, it walks backwards and gathers all the data sets that data set which is being stored. It finds out the dependency of that data set which is being stored and executes all the dependencies. Okay, the other aspects of the nonlinear execution is, although we have said ma- filter 100 times, okay, in our in our pig script, it will execute that filter only once. It will combine all the filters together as a single map. Similarly, it might combine multiple group bys into a single reduce phase, and it does a lot of magic when it comes to non optimization. Okay. Similarly, in case of a split, it will put the if conditions inside the map function itself and then get it done. All right. So that's how the pig works. Uh, Anand's question is split similar to partitions? Kind of, yes. All right. All right. Now, those who have been wondering about Piglatin versus SQL, I think you will get to know more when you learn Hive. Hive is similar to Piglatin, just that in case of Pig, we are using a new language called Piglatin. In case of Hive, we have SQL. Hive converts SQL to MapReduce. Pig converts Piglet into MapReduce. Okay. Now you might wonder what is the difference between Piglatin versus SQL. All right. One is Piglatin user describes exactly how to process the input data. SQL allows you to answer allows users to describe what question they want the answer what question they want to be answered. Okay. Piglatin is generally a long series of data operations, while SQL is all about executing a query. Desi- Piglatin is designed for distributed computing, while SQL was designed for relational database. Piglatin targets multiple data operation and parallel processing. For multiple data operation, you have to, in case of SQL, the query keeps on getting complex and new constructs had to be created. Now, in case of Pig Latin, it can be used when schema is unknown, incomplete, or inconsistent. In case of SQL, it requires well formatted data upfront. All right, that was pretty much about Pig Latin. So, if you have to know more about other details, you should have a look at the functions provided by Pig Latin. Okay, and built-in functions is a great place to look at. All right. Now, in case you want to create custom load function like the way I showed you earlier, how to do the JSON loader and create a custom loader, for example, loading from your custom database. In those cases, you could look at this on how to create the custom data sets. All right. So that was pretty much what we had to discuss about pig. Do you have any questions on pig? Okay. Any questions on pig? Please try to finish the assignment. There are 3-4 subjective questions. Please finish those. Those are very simple questions. So Rohit's question is why we have hidediv.pl twice. Okay. There, where were we? All right. So here, one is that we are saying that we have to execute this command, right? Here we are saying execute this command and ship this program. All right. Sometimes you don't have to ship anything. Sometimes you know that only some other library on which your command depends upon that needs to be shipped. Rest of the libraries are there. So what is it that you want to ship to all the nodes? Something that doesn't exist on all the nodes, on which your hidiv.pl command depends. Okay. Pankaj's question is, do we have to write pseudocode for subjective question? There is one question where you have to write the MapReduce code. It is up to you whether you want to write the pseudocode for MapReduce or not. But for pig, all the questions need to be answered in correct query. No pseudocode for pig Latin. Okay. All right. So now there is a question from Carlos. We see the connection to Oracle with Scoop. All right, probably you mean to ask that will we discuss the importing of data from Oracle using Scoop? We will be using MySQL. All right, be using MySQL. That won't be much different. All right, all you have to do is change the driver. That's it. All right, Carlos. So we'll be connecting to MySQL instead of Oracle. But in case you want to import data from Oracle using Scoop to, if you want to import the data from Oracle to HDFS, it's pretty straightforward using Scoop. All right. There's a question from Peter. What are the situations in which you would use pig versus MapReduce? Okay. Let's take a situation like matrix multiplication. multi Multiplication. Matrix multiplication is heavily custom and would require a lot of looping, right? So in those cases, the pig is not a great solution. All right. But in case of data operations such as normal joining of two tables, grouping, and all of those basic things which you did using databases, those things are very straightforward with pig. Okay. So join operations, I'll go with pig. So mostly the way I do is that I look at the problem and see how can I solve it using pig. And then if I can't solve it using pig, I see if I could just create a user defined function UDF. And if I see that there's like too much of work need to be done using UDF, then compared to writing MapReduce, then I'll go with MapReduce rather than creating UDF. All right. So that's a quick thumb rule to decide whether to go with MapReduce or pick. It's based on your requirement. All right, does it make sense, Peter? All right. All right. So as you try to basically the thumb rule is when you are doing the normal data operations, the usual data operations, whatever you did with SQL, you'll be able to do that using Pig. But when you deviate and you do things like matrix multiplication or some complex operation which is really difficult to do it in Pig, then you go for custom MapReduce. All right. All right. Great. Great set of questions. Any other question before we move forward? All right. I'm assuming there are no questions, but in case you have, just let us know. All right. Let me check the space on my disk. All right. We have enough space. All right. So today we are going to start with our Hive discussions. All right. So MapReduce is great as well as Pig is great, but how will you move your existing users away? How will you move existing users to Pig or MapReduce? There are lots of code. There are lot of code as well as there are lot of data which is lying in SQL, as well as the lot of code people have written in SQL, like various queries, various reports, various stored procedures. There are a lot of work that has been done in SQL, and probably every senior IT engineer today is equipped with SQL. Okay, SQL is one such language which probably most of the people are aware of. Not even that, even people from various kinds of backgrounds, whether they are from the analytics background, they are from chartered accountants, then there are the people who are just from the management. So all of them seem to be comfortable with SQL. Now, you cannot make this change so quickly from SQL to Pig Latin or some other way such as MapReduce. It's like impossible. That's where the that's where that's where the value proposition of Hive comes into play. And we have already discussed that writing MapReduce is not practically possible for every small work. MapReduce is something like custom program which we will write when we have like super specialized need. Okay. So the true value proposition of the Hive is it's most suited for data warehouses when you have to churn or analyze the relatively static data. When you have data which is not flowing really fast or which is not changing too often, and you do not want a kind of per second kind of analytics. Okay, per second as in every second you got to execute this script. No, in those cases, high will not suit. But in case your data is relatively static and data is huge, okay, and you are not expecting an immediate response as in few milliseconds. When you are okay with 5 to 10 seconds kind of response, Hive is great. Okay, it makes it easier to port existing projects. It provides an SQL dialect called HiveQL. HiveQL is designed such that it is very quick and easy to port existing queries. Okay, it maintains metastore for the metadata. Okay, so what we noticed when we talked about pig, what did we notice when we talked about pig is every time you exit from pig, all the data sets that you create will vanish, right? So we said input equals to load blah blah blah. Now this input is a data set in case of pig, and this input will just disappear after you exit from the pig shell, right? But that's not the case with SQL. When you create a table, create a view, or create a stored procedure, it is persisted. It is there when even after you exit and log in again. It is there. It is not. It is not only in the memory. Okay, so the important aspect to know about Hive is that whatever data structure you create, the tables, everything, they will persist in the database. They will be available when you come next time. And how does Hive made it possible? By having something called metastore. Metastore is nothing but a relational database in which this information is stored. What is this information? Information like what is the table name, and what are their columns, what are their data types. So all of this information is stored in the MySQL or Metastore. Okay, so whatever tables you create in case of Hive, they will be kept in Metastore. Now it it allows querying HDFS file and HBase. That is the value proposition of Hive. All right. Now there are some limitations. Before we jump in, we should know about limitations. Okay, I mean, without both sides of the coin, you will get the picture that Hive is the solution to every problem. Okay, so Hive is not solution to every problem. It is always solution to a small data set, a small set of problems. Okay, so Hive is great when we are churning relatively static data and we are not modifying things. Okay, so it does not provide you a record level update, insert, or delete. Although there is some work going on in which they are trying to bring insert, update, and delete to Hive. It can generate new tables. Okay, but it can generate new tables. You can say insert into select from some other table. Okay, it is not suitable for online transaction processing because it doesn't provide you CRUD operations, create, retrieve, update, and delete record wise. Query, the other reason why it can't be used for online transaction processing is because the queries have high latency, as in you must have seen that every query which we executed in MapReduce took around 5 to 10 seconds. Okay, the whole machinery of Hadoop has been designed in a way that it's for heavy lifting. It's for terabytes of data. Okay, if your data is small and you can get things done, then Hadoop MapReduce is not useful to you. So so the way it has been designed is it is designed to have higher latency so that it can handle humongous load. So because Hadoop's design is like get things done, don't fail, no matter if it takes like 10 seconds. Okay, so and that's why we call Hadoop as batch oriented. So startup overhead for MapReduce jobs is there. Therefore, it's not suitable for OLTP. It's great when a big database or big data set is being maintained and mined. All right. So the architecture of Hive is in the following way. The heart of the system is something called driver. Driver is the one which converts which converts the query into MapReduce. You give it a SQL query, internally it creates the MapReduce. Now, this driver talks to Metastore, driver talks to other systems. Okay, driver talks to other systems in order to generate MapReduce. Also, you can interact to driver using either the command line, the way we will show you today, or using the Hive web interface. You can talk to driver using the web interface as well. Also, you can talk to the driver via service called thrift service. Thrift service is a binary service, as in the way other clients call this thrift service is by binary protocol called thrift. And so thrift server can be called from JDBC and ODBC because it's not stateless like HTTP. It's a stateful protocol. Okay. Now, connection to Hive could be from Hue or Qbol, or there are many web viewers which make it possible to talk to Hive. Okay, and Hive's driver talks to Hadoop to get its MapReduce executed. All right, so that's the ecosystem of Hive. All right. Now, this is a quick view into the word count. No problem is complete without this hello world example of ours. So this is how you do the word count in SQL. You first split the line by a certain character, which is space here, and then once you have split it, you explode. Explode converts this array into one word per row. Okay, one word per row is generated because of explode. And then we could do a group by, and after we have done the group by, we could do the count per word. Okay, and once that count is done, we store it into word underscore counts, and at the end of it we are saying select star from word underscore count. So that's how we the create the word counts. And also, before starting the process of creating table, we load the data. So we created a copy of our data first. Then once we have created the copy of our data which we are trying to load is word count, then we loaded that copy into the file from HDFS itself. Now once we have created the table called docs from HDFS, then we shall be able to do the rest of the work. You can see that we are selecting from docs and then doing the rest of the magic. So that is about word count example. All right. So, all right. Now, how to get started? Either you could go to the command prompt right away, log in into CloudX Lab, and start using Hive. You could simply use, not here. All right. So you can see that this is our prompt. Show tables. All right, so this is the prompt from where we can run. So you can use Hive on H2 and H3. Do not avoid H1 right now. because H1 is overloaded with name node and resource manager. Okay. Yes, slash s means space. It's a part of regular expression. All right. Now you can call Hive without any argument. In that case, you will get the prompt, and from there you can interactively get your queries executed on Hive. Second is, if you're just looking to execute a single command, you can call hive minus e and the command name. If you are having, if you have noted all your queries into a single file, you can execute that single file using hive minus f. Okay, that's a hive script execution. All right. So to get started, let's say we have this. We are saying create table x, select star from x. There are no records and then drop table X. Alright. Also note that Hive does not provide any insert into or update or delete. Alright. Now on the prompt of Hive, you can run HDFS commands using dfs minus ls. You can try that. Alright. Or you can also load some external script using this. Okay, so it is saying that it's not as valid SQL file. You can create your own file and load it from the command. What else can you do? You can put the commands if you have some commands. uh, it doesn't accept the commands in the command prompt, but in the script it does. Also please note that the environment variable are set using years. The way we talked about environment variables in pig, you could do the same thing in hive as well. Sometimes you, instead of you exiting this prompt, you can call your commands from here, the local ls commands. Okay, the local system commands by putting exclamation. Okay, so you can do that from here itself. You can see that. All right, you can see that we were able to call, let's say we want to delete this file, so we could say exclamation rf pig underscore star dot log. All right, although it doesn't seem to work. It doesn't seem to work. Anyway, it doesn't seem to work because the asterisk is not expanding. Never mind. But yeah, we are able to execute some commands. Carlos's question is about the create table command using use a table space parameter like Oracle. Yes, you can use that. All right. So if you tell me, then basically most of the commands of Hive are structured around the syntax of Oracle. All right. Sometimes the things vary, but you should try it out and test it. Yes. Rohit is saying create table command creates table under any database like SQL Server. Yes, it does. All right. Good. So Like with every query language, we have data types in Hive as well. So it starts with numeric data types. Numeric data types are tiny int, small int, big int, float, double, decimal. Now, there is something interesting you should notice here. As the versions of Hive are growing, they are introducing more and more kind of data types. Like for example, binary was introduced in point 0.8, while varchar was introduced in the version 0.12 of Hive, while char was introduced in 0.13 in Hive, and it's evolving on every release. The main reason is Hive wants to be compatible with almost every database out there, and that's why you see there are multiple integer types like tiny int, small int, big int, and you will see more and more of data types. Similarly, you have boolean as well as binary, you have string as well as varchar as well as char. Okay, so to do the same thing there are many data types. You have decimal as well as double. Srini's question is, what is the use of creating a table in Hive when we cannot insert in that record? But Srini, we can load a data into a table. We can create the whole table from an existing data. All right. And therefore, if we can do that, then we can analyze our data using SQL. Yes. Srinivasan, you have a question? You raised your hand. All right. So that's about the data types. Now there are some complex data types which are there as part of the core Hive. There are data types like arrays. Arrays, as in we define a data type with a keyword called array and then define the data. So array is a sequence of values of the same data type. Similarly, you can also define a data type as map. Okay. And when you define the map data type, you have to define the two things. One is primitive type and other is actual data type of the value. So what exactly is a map? Map is a collection of key value pairs. Then therefore you have to define the data type of key and data type of value. Key can only be primitive while value can be anything. That's map. And then you have struct. Struct is nothing but hard coded keys and values. Okay. Values, struct is like your map, just that the keys are hard coded values. And something, there is another interesting data type called union. Union comes from, so these data types are amalgamation of the data types from Oracle and Postgres. Okay, I don't know much about Oracle, but I know for sure that in Postgres all of these data types are there. So union type is an interesting data type. Union type says that a particular field can have value from either of these three data types or four data types or whatever. It can have either of these values, and it will consume the space equal to the maximum data type under union. Okay, the biggest data type under union. So the interesting part here is that union type can store multiple different type of values. For example, in this case we have auth. Auth is a union because imagine you are having an authentication system. User might have authenticated himself using their Facebook ID or Google ID, which is integer, or maybe an email address, which is string. So integer or string is being stored in the same column. So that is the idea behind union. Using union, you could have different values in the same column, different type of values in the same column. All right. when you are very sure that only one of these things would be present at a time, in those cases you use union. All right. Now, starting with something called namespaces or database space. Okay. So, like every database, every system, Hive also has a concept called databases. In databases, you can create as many tables as you want, and a database is basically a placeholder for creating tables. Okay. It helps us organize, or it avoids the collision between the work of two people on the same cluster. Okay, so you have show databases command which shows the existing databases. So you can try here, show databases. So we have these many databases. We could say use this show tables. So you have these tables, stock data. All right. So similar to SQL tables, you have tables in Hive as well. So you can see the way I just showed you, show tables and select from some table. Also, the way we did just now, we could also do things like describe describe my stock data. See that? Okay. If you want a more detailed view, you could say describe formatted. Describe formatted is better than. Okay, it shows the detailed analysis of the report of this table. It shows that. All right, you can see it shows you what are the columns does this table have, and then on what date it was created, who is the owner, what is the location of the data. Okay. All right, so that's how you can talk to the tables. There's a question from Anand. Let me try to answer it. Question is, how can we handle exception in either pig or hive since MapReduce is generated by the system automatically? All right. So you generally do not have a control over exception handling inside MapReduce. Okay. In case of your pig or hive query, you will have to utilize a similar way we do it in SQL. Okay. So there is no try catch kind of model inside pig or hive. All right. Now those are the tables in case of our Hive. Now there are two kinds of tables in Hive. One is called managed table, other is called external tables. So managed tables are the your tables, while external tables are the tables which load the data from outside. So managed table is something when you delete, it deletes the data as well, while external tables, if you delete, do not delete any data, instead they just get dropped. Many external tables are more like symbolic links in case of files. So lifecycle is managed by Hive in case of managed tables, and data is stored in the file you added. For example, all the tables which we just created using create table, there was one example where we said create table X. So that table was managed table. Okay. Now, since Hive is mainly primarily used to churn the data, so you might require the data sets from different data sources, and that's where the managed table external table comes into play. All the external tables where you don't want the data to be dropped when you delete a table. When you delete a table, if you don't want the data to be dropped, make it external. You can explicitly say create external table. I'll show you this. All right. Now, what exactly is Hive Metastore? It stores the metadata of table into a DB. You could do a you could log in into MySQL. Let me try MySQL. Oh, it's not allowing. All right, I'll have a look at it. So right now we are not able to see the MySQL, but nothing to worry. So basically, this meta store is saving the data into Hive. Sorry, Hive is saving the metadata into Metastore, and Metastore is just very thin layer. Okay, internally it's storing all the information into MySQL. What exactly do we mean by metadata? Metadata is what are the name of various databases in MySQL in Hive. What are the name of various databases? Now, what is the name? What is the column names of what are the column names in a table? Okay, what are the column names in a table? What are their data types? Okay, all of this information is part of the Hive metastore. Okay, Rohit's question is what is describe extended? When you want more detail about a table, then you use describe extended or formatted. Okay, I personally prefer formatted over extended, because if you say extended, it will not be well formatted. Formatted is nothing but extended plus format, well formatted. All right. So yeah, Anand's question is it possible to create index on Hive tables for better performance? The answer is no, because when we talk say performance is in terms of map reduce, and if you create the index on this table, that will not be taken into account while doing the map reduce. Okay, so there are alternatives. There are alternatives such as such as part, partition table. All right. All right. Now let's talk about managed tables. I don't know what has happened to my Hive. Something wrong with it. Alright, so what exactly is Metastore? We have talked about it. Now let's talk about managed tables. Alright, so any table you create without any external keyword is called managed table. So we are creating here a table called NYSE daily 29 September, okay, or we can simply say employee or say NYSE. Okay, let's just say NYSE here. So what exactly is going to do is going to create a table with these columns. Okay, we are creating a table with these columns, and we are saying here, please pay attention here, we are saying row is formatted. Row format is such that the fields are delimited by /t. Okay, so and the location of the file is here. So whenever we load the data from NYSE, it is going to go to this location, load the data from that location, and then break down the fields based on /t and display it to the end user. Right? That's what is going to happen when people try to do select star from NYSE. Okay, in case under the hood this table got changed, the data got changed, and we did not change the row format, then it will keep on giving us errors. All right, so this is how you create a managed table. This is how you create a managed table. Question from Pankaj Singh is where managed tables and external tables will be created. The metadata of both will be in Metastore, while in case of managed table, the location will be in HDFS, while in external table, the file the data need to exist already. Okay, external table could be loading data from an external location, say AWS, or it could be locating from local file system. I mean HDFS also, it can load the data from HDFS also. All right. Now, all right, finally it has loaded. So let's try to create this. All right. If we do not provide a location, it will create the data by itself. It will create the location. It create this table somewhere in the file system. I'll show you. Describe NYSE, or we can say describe formatted. Okay, so here you will see the location of the file. Here you see by default it creates the table in this place called apps hive warehouse NYSE. You can go into HDFS and check if it exists or not. By default, all the managed tables of hive are created in this warehouse. All right. So Srini's question is, if Metastore is keeping only the metadata, where will the data stored belongs to is stored? At this location, what we just showed you here, wherever we have created this table. Either we could explicitly mention the location where we want to create the table, or it will create, if you don't mention the location, if you do not mention the location, it will be in this place. All right. So uh, Anand's question is, are managed tables similar to views? We cannot say tables that are equal to views, because there are views also in Hive, so it will confuse all of us. Okay, so managed tables are kind of, how should I say? Managed tables or any kind of tables are basically tables where their data is in Metastore, and the actual data is in the file system, and every time you query these tables, the data is loaded from the file system, and when if you do the churning, it will call the MapReduce. All right, so this was our manage table. Now if you have to load the data into managed tables, you will have to create so let me try to. So we just created NYSE. Let's load the data into it. Okay, so we'll say load data local in path. Okay, now first we will try to. Okay, we could load the data from the local file system. And how should we do that? Let's first copy some files to local file system here. Where is my local file system? Let me just copy that Hadoop fs Hadoop fs copy to local slash data slash nyse. Okay, so now there should be, do you see that? So here, uh, where was that example we were talking about? Yeah, NYSE daily. Okay, let me just copy this NYSE daily file. Hadoop fs minus copy to local. Where is NYSE? Yeah, here it is. All right, let's try to. So we just created one manage table like this in Hive. Now let's try to load data into it. I said FG. FG is to bring something which is running in the background to foreground. So let's say we have this table and we want to load the data into this table. So what we do is we say load data local in path, and we say NYSE dividend, and then we say overwrite into NYSE. NYSE, that is our table name. So it's now it has loaded the data from my local file to this table called NYSE. Select star from NYSE. See that? We can say describe NYSE. Okay, and then we can start doing something like symbol. We can start doing all kinds of operations at this point of time. Select NYSE where symbol equals to CVA. See that? So we were able to query very quickly from a table. Okay. All right. Sometimes you want to load the data from HDFS directly to Hive. Just now, the one which we used just now, we loaded the data from local path. Okay, local path. Now what we want to do is we want to load the data from HDFS. So before we do that, let's create a copy of the data which we are trying to do. Okay. So let's try to create a copy of it. So as we were telling, we could say dfs minus copy. And what is the data we want to copy? We want to copy the nyse daily file out. Dfs minus cp slash data nyse, and I will say in my home folder, or I can say nyse copy. Will it work? No, I think we'll just use Hadoop CP. Hadoop CP minus Hadoop FS minus CP data. Okay, we'll just call it one. Alright, Hadoop FS minus LS. Yeah, you can see that. This is the one which we have just created. Now let me go back to Hive and say, so we have copied the data to our home directory. Now we can load the data into our Hive. Okay, so we can say load. Okay, so we can say load data in path. And what was the name? This was the name of our file. Overwrite into table nyse. We are saying load the table. Just a second, I had to put the single quote around here. So this is what we were supposed to do. Not here, sorry. Alright, now we have loaded the data into that, or we could also say delete from nyse. Alright, so what we have to do, we might have to create this table again, or we can also do something. We could delete the underlying data and it will work fine. Okay, we could delete underlying data and it will work fine. Alright, so let me just try to delete the underlying data. So underlying data was where? Underlying data was in this location, Hadoop fs minus ls slash what was that? Apps hive warehouse. Okay, so here there is nyse file. Let's try to delete it. Can we delete this? I think we can delete this. Hadoop fs. Will it work? So now we have deleted the underlying data, and if we do select star from NYSE, there will be nothing. Select star from NYSE. So it says there are no records, correct? Now we can, so whatever we did earlier when we loaded the data using this command, okay, we loaded loaded the data from this previous command where our data was in the local file directory. Now we are trying to load the data from, notice that earlier there was a local keyword, now there is no local keyword. All right, so it is asking us to provide the home directory path. Okay, so what was the name? I think it is this location. What is the location of our folder? T797974, our home folder in HDFS. What is the location? Say Hadoop fs minus pwd. How do you, okay, Hadoop fs minus ls, and okay, so where did I create? Is that the folder? This one. All right. Let me just put it again. Hadoop copy Hadoop fs minus copy from local nyse nyse daily file into there. Okay. All right. Now we have this, and all right. Now we have successfully loaded the data from our HDFS. Okay, so we have successfully loaded the data from local file system using the command like this, and successfully loaded the data from HDFS. Now please note that whatever right now we have, if we delete the file, then data will get deleted from here, and if you drop this table, then the data will get deleted from the file system as well. Okay, so you can delete if you drop the table. So here we are talking about a table called NYSE. If you say drop table NYSE, the data which we just created, you remember we copied this from local to HDFS, the same file would have been deleted by now. So be aware that you might end up deleting a lot of data. Okay, so the file is no longer there. All right, so uh, a little quick recap. We created a managed table by saying create table simply without specifying the location. So the table got created in the slash app slash hive slash warehouse HDFS location. So when we want to load the data into this table, we said we use the local path, as in the local directory. We we could upload the data from local directory directly into the table by using load data local. But if we want to load the data from HDFS, we used the load data in path this. Now please note that if you are loading the data, if you are loading the data from HDFS, the data will get to moved to your location. Okay, it's not copied. The way the data got copied when you loaded the data from local directory, in case of HDFS, the data will get moved. When you say load, the data will get moved into the warehouse folder. Okay, this is most important aspect, because if you delete the table, the data will get deleted, and that's the reason why we avoid creating the managed tables. If your data is by default separated by control A, then you don't have to mention this particular clause. If you don't mention that my row is formatted and separated by /t, okay, if you don't mention that, it will expect the data to be separated by a special control character called control A. Okay. So while loading the data, if the table is partitioned, it will create a partition table. If the table is not partitioned, then you can omit the partition. Okay, so data is stored on HDFS. All right, now now we have actually deleted the data. Anyway, we have shown you that we could we were able to query from a Hive table very quickly, where we used select star from NYSE, where symbol equals to CVA. All right, so that's about creating a table and querying the data. We could do a lot of quick querying into this Hive table and get the results. All right. Now Srini's question is, okay, we have answered this question already. Anand's question is, when we load the data, commit will happen automatically. Yeah, there is no transactions. Okay, there are no transactions in Hive. There's a question from Rohit. When moving from HDFS to Metastore, when moving data from HDFS to Metastore, does it remove replicated data too in HDFS? So we are not moving data from HDFS. When we are saying data from load data from our HDFS directory, okay, so what exactly are we doing? We are moving data from HDFS to when we load the data from HDFS, it moves to the place where our table is storing the data. Our table is storing the data at the warehouse, as in /hive /app /hive /warehouse. Okay, so this folder, whatever you are loading from, it will get moved to the location where your table is there in HDFS. So it's moving from HDFS to HDFS, although it does create the metadata in the metastore while we are creating a table. All right, Rohit. Question from Srini is, if we load 1 TB SQL database into multiple tables in HDFS by using Scoop, how the data will be stored in HDFS? Yes. In HDFS, it will be loaded in the same way, the way we have just done. So whenever we put the data in Hive table, it's actually storing in the HDFS. Okay. That HDFS, we all know, stores the data in the blocks. of 128 MB and so on. All right. I hope I'm able to answer Srini, Anand, and Rohit. All right. So we were able to load the data. We were able to query. All right. So the data is either located at this place in HDFS or the location you have mentioned in the table definition. You could see that in the table definition, we have mentioned the location here. But for example's sake, we can remove this and try running. It will create the location at this place. All right. In case you want to download the data from your table into, you want to export the data, in those cases, you could say things like insert override local directory, temp only CMC, and select star from that particular table. So it will bring that data and put it in that format in which the table is formatted. In our case, it was slash t, tab separated. So we will get the data in this file called tmp only cmc in a tab separated format. Okay. In HDFS, when you insert overwrite the directory, then if you want to store it in HDFS rather than the local file, sometimes the data is really huge and you want to keep it subsection of it in a separate file, then you can basically, instead of saying local, if you omit local, it will save it in HDFS. All right, whatever subsets of data you have. Pankaj's question is, Hive table and data will be stored in HDFS. So for Hive table, also HDFS will do the replication. Exactly. Yes. So for Hive metadata, there is no replication because it's going into MySQL, but for Hive data, you have replication. Okay. All right. We will talk about partitions in the next session. If you have any questions, you can ask now. So with this knowledge, what we have done so far, loading the data and querying the data, you can continue to solve the problems mentioned in this exercise. Okay. All right. We will discuss this and NoSQL in the next session. All right. And we'll continue our discussion in detail. All right. Zuan's question is, the partition is done by the range list.hash also. Yes, we will talk about it again. We'll talk about it in the next session. Okay, Azwan? All right. Thank you very much. Have a great day. Bye bye.